Alright, so today we're doing a thing called perpetuities. Now, perpetuities are a type of annuity, and what makes them different to other annuities is that the payment you receive is equal to the interest that's earned. So you can, I think of a perpetuity as an investment version of the interest-only loan. So the payment equals the interest earned. Right, no more, no less. And the word perpetuity comes from perpetual. So if you're only taking out the interest, then what you put in there in the first place always remains there, and it just continues on and on and on indefinitely. So your payment received then is equal to your interest earned, and so that means that your payment you receive, we always use a D for that. Interest rate, turn the rate and percentage per compounding period into a decimal by dividing by 100, multiplied by our initial value. Alright, so because we're only taking out the interest that we earn on our initial value, then this always remains the same. So V0 is our initial value, up little r is our interest rate per compounding period. And D is our payment we receive. Alright, 3 examples. Out of your textbook. Alright, example 14. says Elizabeth invests her superannuation payout of $500,000 into a perpetuity. All right. So as we go, V0, 500,000. That will provide a monthly income without using any of the initial investment. Just kind of doubling up there because that's what a perpetuity is. Effective rate of the perpetuity is 6% per annum, and we've got monthly payments. Okay, and we now want to know what she's going to receive. So first of all, before we use our formula, we need to adjust our interest rate. So it's for 6% per annum, and she's receiving monthly 6 over 12, which is 0.5% per month is what she's receiving. So her payment, then D equals R100 times V0. The R we've just worked out to be 0.5. Divide that by 100, times it by the 500,000 that she has invested, and get an answer of 2,500. So on that investment, Elizabeth would receive $2,500 each month, and her initial $500,000 that she put in would stay there. So provided the interest rate doesn't change, this is what she's going to earn each month in her payment to live off. All right. Next example, example 15. $339. Okay. So in this example, previous example, we worked out how much the payment was going to be. In this next example, what we're going to look at is how much money we're going to need to put in to get a certain payment. So example 15 says how much money would need to be invested. So that's our V0. How much would we need to invest? Earning interest rate of 4.2% per annum. Compounding monthly, I think it says. Yep, monthly. And in this one, we know that we want a payment of $200. So we're wanting to figure out how much we would need to put in. All right, so first of all, before we use our formula, we'll change the interest rate to the monthly. And to do that, I
Divide by 12.
4.2 divided by 12. Because I've prepared one earlier, that becomes 0.35% per month. Okay. Okay, so the payment we want is 200, and that's going to equal 0.35 over 100 times by how much we're putting in. Alright, so we could rearrange from here if we wanted to, or we can go to our calculator and use the solve function. And on the calculator, solve equals, you then go, and I'll show you how to do this in a sec. Go to 0.35 over 100, we can use the fraction template. The calculator doesn't have V0, but what the calculator does have is on your keypad X, and then the comma X. Sometimes just telling the calculator what you want it to calculate. Sometimes you need this, sometimes you don't, so I suggest just put that in anyway, just in case. And then your calculator will then do all the rearranging for you. And remember, you do have your calculator in both of your exams. Alright, so calculator, solve function, where do I find it? You can find it on the keyboard, yep. Down here. So click on that. What are we solving? We're solving that equation, which was 200 equals, use the fraction template that's on your keyboard, 0.35 over 100. Don't forget to click across, see how I've got a big cursor there, and then it's only little there and there, so click it across, and what do we want to do? We want to multiply that by x, and we want to find x. Then you just go EXE, and I've got this fraction now. Can anyone tell me why I've got this fraction and not a decimal?
Because it's in standard form.
Because it's in standard. So this here, if it's standard, it's going to gives me that fraction. Now you don't need to panic and re-enter stuff. All you need to do is just click on that standard. It's now changed to decimal. Go EXE again, and there you go. It's calculated it now as a decimal. So how much have we got to put in?
$57,143.
Mm-hmm. $142. If you want to be really fussy, 86 cents as well.
It said to the nearest dollar.
Did it? So to the nearest dollar, that is
143.
143. Okay. All right. So those two questions we would do using the formula. Example 14, we probably could do that with our, yes, we could do, this one we could do with the financial solver. This one here we can't do with financial solver because there's too many things we don't know. Right? So we don't know the initial investment nor the final value of that investment. So we can't use financial solver for this one, but we could have for that one. All right, let's have a look at the next example where we do use the financial solver. All right, so that's 16. Example 16, still on page 339. Okay, so it says a university mathematics faculty has $30,000 to invest. So that's going to be our initial V0 or our initial value. Now we're talking about here with this, we're talking about using the financial solver. So let's put in.
I'm just grabbing your calendar.
Sure. Put in the things that we are interested in. So our present value is 300,000. Now, does that need to be positive or negative?
Negative, because
Negative. All right, they're investing it, so they're putting their money in, their money's going away to whoever's investing it.
I think it's 30,000.
30, not 300. Right, thank you. There we go. It is 32. All right, intends to award an annual prize of $1,500. So what's that $1,500? Payment, yep, that's our payment. And positive or negative?
Negative. Positive.
Positive, because they're going to take that 1,500 back and then award it as a prize. So they've invested the money, taking the 1,500 back each year. All right. Interest rate. That's what the questions asks us what interest rate that we want. Now the other thing is the final value. So after that payment's taken out, what's the value of it going to be?
The same.
The same. Yep. So that's a perpetuity. The perpetuity, point of a perpetuity is that this 30,000 doesn't change. That always stays the same. Now this can be the tricky bit. Is that going to be positive or negative?
Negative because it's still there.
Not negative because it's still there. Positive because it's their money to take back if they wish. Alright? And generally these are going to be opposite with these. If this is negative, that'll be positive and vice versa. So they put the money there in the first place. So they've given away the money and it's sitting there, but it's still their money that they can get back. Right. So it's a plus. What else? Now the question is, what might be used for N? Alright, so often the technique that you will use here is, so they don't actually give us much in the way of an idea about what N is. This interest rate we're talking about per annum. So what we can do is we can say, well, let's make N equal to 1. All right, and we can do that because all compound periods are the same. All right, so the number of payments per year, well, I only want to do that once a year. It's an annual prize, I think it's what it says, doesn't it? An annual prize. An annual prize, yep, so that's once every year. So we only need this payment once in the year. And so we'll put our compounding as 1 also. Again, why? Because they don't give us any indication as to that it's any different than the how often the payments occur. So we use 1. All right. I think we need to go and put that stuff in our calculator. Let's turn this around and let the YouTube people see this if they can. All right. So we go to our menu, second page on my financial. Change the numbers I need to. N needs to be 1. The interest rate's what we're looking for, so let's just clear that at the moment. We put in 30,000. We want a 1,500 payment. It's going to be 30,000 still sitting in there. We're going to take the payment once in the year. And we're going to compound it once in the year. Alright, so now you go up here, either put your cursor here and press solve or click on the button. And when we do that, it says
Five.
5. So we need to get 5% per annum is what we need to, or the maths faculty, what they need to get on their $30,000 so that they can award a $1,500 prize. All right, last thing, a summary of annuities. There's 3 things that can happen with annuities. So let's do a summary of annuities. All right, so first of all, first thing is if the payment is less than the interest earned, what do you think is going to happen then to the value of the investment?
It'll increase.
It will increase, exactly. The value will increase. If the payment is more than interest earned, what's going to happen there?
The value of the share will decrease.
Yep, the value will decrease. And the third option is the one we just looked at. If the payment is equal to interest earned, what happens?
Figure stays the same.
The value stays the same. And this third one, this is a perpetuity. This is the perpetuity. All right, and we'll just keep continuing. All right, so it doesn't mean there's anything wrong with these other 2 things. These other things are fine, depending on situation. So, like for example, if you're a retired person, you're probably going to look at the second option, where the value decreases, and you're not going to live forever. So, if you're a retired person, you don't want necessarily, you're not going to want your value to increase, because when you cark it, your kids are going to get too much money, so you want to try and use your money up so your kids don't get any.
Fair enough.
Yeah. Unless you really like your kids, and then you might. Alright. And then, often people have prizes and that would be looking for this, or the increase, or the equal, so that those monetary prizes can continue year after year after year. Alright, anything there? No. I forgot to show the YouTube people that last bit. Better turn around and show them that last bit they've written down. So YouTube people, you're going to have to pause that if you want to write that down. And even though Sam's not here, I haven't forgotten, like and subscribe.